We're proud to be speaking in front of you guys today. Thanks for making it out to DEF CON Day 3. I know that's hard for 90% of the audience, so we're glad that you're here. First, we're going to start with the agenda. We're going to go over what the attack surface looks like on the cell phone, what kind of things you can fuzz, what's available to you. We're going to be talking about some testing environments, both virtually and a real world test environment. We'll be doing some live demonstration at the end. Oh, yeah. All right, so my name is Brian Gorenc. I run the vulnerability research team inside of HP Security's research organization. My primary responsibility is running the Zero Day Initiative, which is the world's largest vendor agnostic bug bounty program. I'm also responsible for running the Pwn-to-Own competition. Through these programs, we've been able to inject over $10 million into the white hat research and vulnerability marketplace. We're quite proud of that. Outside of that, I do a lot of fuzzing and bug hunting, but typically they don't lead to vulnerabilities, only once in a while. So I'm Malicious Input on Twitter.
Hi, my name is Molinyawe. I'm a security researcher. I work for Brian. I look at POCs that are submitted to the Zero Day Initiative. Untrusted pointer DROs are my favorite, and Brian's favorite too, because pointers from the internet are really hilarious. I mean, bad, anyway. I measure my productivity in hours of YouTube that I watch at work, because I work a lot. So, I also was part of the Pwn for Fun team that exploited Internet Explorer 11 on Windows 8.1, and I did a lot of cleanup. And it's best to clean up your mess after you exploit, so you know it rides clean and it's shiny. And I like scientific calculators. In my free time, I go under DJ Manila Ice. I was a 2-time United States finalist in the Cool Mix in the DMC, and those are some prolific DJ contests. I also scratched on the 2014 Pony nominated song "Security Kate" by Dale Chase. I also beat Contra using only the laser without dying. You can see it on YouTube. I did in like 17 minutes or so. I beat QWOP, national hero status. I do martial arts, so if there's anything I want to say is do the shit out of the things you really, really like to do. My name is DJ Manila Ice on Twitter too.
All right, so the whole point of this talk is it's a 20-minute talk. We've got a lot to get through, but it's about what it's going to take to actually build your own SMS MMS Fuzzer. What we like about this technology is that there's a lot. It's always on. It's always in your pocket. There's limited inline defenses between the phone itself and the attacker. Everything goes through the carrier networks typically, and so there's not much defense built up in there. And there's limited update capabilities. A lot of the phone vendors nowadays, outside of Apple and Google and those guys, once the phone is actually entered the marketplace, it's basically EOL'd, and there's no engineering team out there ready to push patches, and there's no real clean way to get a patch out to the field. We've experienced this a lot inside of the Zero Day Initiative when we've been trying to get patches out for the mobile Pwn-to-Own contest. It's quite difficult. There's been a lot of research in this area, of course, and it seems like everybody seems to be rolling their own fuzzers and doing all their own mutation. So what we're going to try to do is give you some building blocks for you to get into this area and get interested in phone fuzzing. In this case, we're using Android devices in this demonstration. So first off, let's talk about bug hunting itself and what's available on the phone. For messaging services, we have not only SMS, short messaging service. It's a store and forward technology. Many of you know this. But there is actually different encoding sets and different alphabets that you can send to the phone. You can send a 7-bit alphabet to the phone. I think it's 160 characters, 140 character 8-bit alphabet, and a 70 character UTF-16 alphabet to the phone. You can overlay messages and do segmentation in these messages using their user data header. And so that is available to you, so those are good ways to, there's usually processing errors in that type of segmentation. Multimedia messaging services is basically your gateway into sending malicious audio files, video files, and pictures to the phone. Most of these are processed without user interaction. It allows you to get possibly a shell really quickly. And finally is the commercial mobile alert system. There are 3 different types of alert messages that can be sent to a phone. One is called presidential, one is called imminent threat, which is typically weather, and then there's Amber Alerts. The interesting thing about this type of messaging is the user can actually opt out of the imminent threats and the Amber Alerts, but they cannot opt out of the presidential alerts. And as a result, if you can find a vulnerability in the presidential CMAS message, you're going to own a lot of people that way. And you can see this actually on the screen, there's a messaging crash that we actually got yesterday while we're sitting in the hotel room. So enjoy that. There's a lot of file formats that are available through the MMS protocol that will allow you to get code execution on the phone itself. We listed some on the slides. We've actually just grepped the source code looking for the handlers for the various file types. One of the interesting things is there's a lot of legacy formats on the phone which are typically coded a long time ago. They probably haven't gone through a secure SDLC lifecycle, and as a result, there's probably easy bugs sitting in there. We found a bug or two in the file formats while we were fuzzing. When we're talking about fuzzing frameworks itself, there's a lot of existing work out there that you can leverage. If you need fuzzing seeds, there's always good locations like at libav, mplayer HQ. You can also Google just file type, the file types that you want to fuzz, and get a large corpus of data and send them through their mutation libraries, and then send them to the phone like we're about to show you. You can also get mutation libraries for VCALs and PDUs and things like that. There's a lot of prior research in that area. In this case, we used Redamza to do our mutations. You'll see that in a video later on. And it's actually pretty easy to do crash triaging. You just roll your own GDB wrapper, create a web app, and have a database to store all the crashes. So I'm going to turn it over to Matt. He's going to go over emulation.
All right, for a virtual lab, we just pulled down Android SDK. It's listed there. You'd use these commands to create ARM devices. And you could go through the UI by that command. It's easy to have the scripts rolling. So for iOS, there wasn't a default messaging app on the emulator, but that shouldn't stop you from running any multimedia messages, or multimedia files. And for Windows Phone, the link is there. It has a messaging app. It looks pretty dope. I didn't get a lot of time to play with it very much, but you can attack it from there. As far as Android emulation goes, we used two things. I used the Android SDK, which gives you the benefit of all the API versions from 1 to 4 dot something. And you can have ARM images and x86 images, but they tend to be slow because they're going through, I believe it's QEMU, like emulation. But emulation is slow because it's emulating ARM instructions on your x86 or 64. And with Genymotion, it's a fast x86 VirtualBox virtual machine. It's pretty user friendly. It's available with Genymotion. For debugging, I ADB shelled in and issued this command. This slide is mainly for me because I forget stuff, and I will copy and paste this later. I should probably write a script, but I don't know. I'm super lazy. I need to get on that. A lot of smart people can do this probably faster than me anyway. So anyway. You run GDB, find your process, forward the traffic, pull down the NDK, run the pre-built GDB for your ARM, and then run the target remote command, and then your live debugging. You just continue, and that's it. And if you want to be cool, run Python and catch all the output and send the commands, and that's all she wrote. And you can send it to a web app or database. So for scripting and automation, basically, you can script SMS commands through the send PDU command on the telnet channel. There's a lot of prior research here. I'm not going to go into any detail about that. A lot of the gods are there, and they've already done that. So, so I had to try and tackle MMS, and I failed pretty bad. It was really awesome. It was about 3 or 4 weeks of me telling me, talking to myself, saying, man, why do you suck so bad, Matt? This is awesome. So, yeah, you guys should just, if you guys have any fails or whatever, well, you won't have to. I mean, you'll see how much I failed. But anyway, if you guys should fail fast and fail often, and then you'll eventually get success. But luckily for me, I just completely gave up and went straight to backing up MMS messages with an app called Easy Backup. So, I did that, and I pulled stuff from my phone and threw it onto an emulator, and that's when I knew that putting MMSs on Android emulator is possible, despite what the internet said. I Googled for 3 weeks and it sucked because I was not getting success. So anyway, decompiled the code, it worked. Found out that the SMS.db file is where all the good stuff's stored. And I figured, hey, I don't have to write Java because I did that for like 7 years and got really tired of it. So I'm just going to write Python and insert. So that's it. Okay, so those two directories that you see there is where the database lives and where your assets go that your database will point to. And those tables that you see, that's I figured all that out by just sending a text message to myself or a picture message to myself, and it would be in the sent folder but couldn't send because the emulators can't talk to each other. So I basically just saw how the database was affected, and after that, played with the values, and I could get all into your inbox after that. So you just push the database back to your phones, reset the permissions, and you're set. And basically, you can send taps and clicks to the phone with Monkey Runner, and it's Python scriptable. Here, I'm going to go ahead and play this video. Basically, with this, I'm pulling down the database and generating a bunch of test cases with Redamsa. And I just pulled down the Pwnone pictures. And now it's inserting the test cases into the database. And I believe the next blip, you'll see a little bit more. So now it's inserted the database into the phone. And now it's sending all over the JPEGs that were mutated. Now I'm restarting the phone. Yeah, Emulator's a little bit slow, but that's cool. So you reboot the phone, it'll reinitialize the database and start loading the stuff into your messaging app. Here I am logging in. If you see the red, it's working really hard. Yeah, so it's working really hard processing stuff. And here we are clicking the messaging app. It's going to work hard again. And there you go. There's like 1,000 messages that I threw into the emulator. And now I'm going to go ahead and click through one of them. And this is a big deal because I thought this was not possible. But hey, it's working. And now you can click through your Mangled test case. And cool. So that's our picture that we insert into the database. This next test case, I'm sorry, yes, is that right?
Yeah, go back.
Go back, okay. Yeah, this next guy is a picture of the Keen team from Pwnone. Like I said, I pulled down a big corpus of hacker pictures from Pwnone because I thought it'd be funny because then you could have like a yo dog situation, like yo dog, I heard you like hacking. Here's a picture of some hackers hacking. I'm going to screw up this joke, but anyway. All right, so now I'm going to turn it over to Brian, and he's going to talk about keeping it real.
All right, so for the real world lab setup, you're going to need a set of receiver transceivers to actually send messages to the device. We've been using the USRP in our lab. The Blade RF supposedly supports OpenBTS now, but there's a bunch of SDR devices out there that will allow you to mimic a base station that actually get messages onto your targets. Next is emissions control. If you are trying to find 0 day, it's probably best not to be blasting that 0 day all over the place because somebody, especially at this con, is going to pick it up. And so we've got a RF enclosure up here on the stage. This is what we use. We'll talk about that more later, but it will actually isolate all of the radios inside the box so that you don't lose your O-Day. Next is the software. We're using OpenBTS for our fuzzer. It mimics a base station, and it's very handy with the USRP. And then you need your cell phones, of course, and your SIM cards to actually connect them to the network. When we went to go try to do OpenBTS, I also failed heavily, and Matt ended up having to set it up for me because I'm a loser. So we used a combination of source and binaries.
Just remember doing performance review.
Yeah. So we used a combination of source code, some from Range Networks and some from whoosh.net. We referenced whoosh.net quite heavily when setting up OpenBTS. Because we're using an Edis research device for the USRP, you have to build OpenBTS with the -- with the UHD compiler flag to actually get the correct transceiver in there. So that's important to know. And the UHD drivers for the Edis research device actually come from Edis research. The link is on the slide. And they'll provide you a set of tools for actually flashing the USRP, getting the correct firmware on there, and understand what exactly is in your USRP. For those of you who haven't seen a USRP, that's what it looks like. You can more than welcome to come up after the talk and take a look. We're using VERT 900 antennae to actually do the waves, and the SMA cables to connect it to the RF enclosure. The RF enclosure looks like this. It's a Ramsey test equipment device. It's used for forensics investigations. When they grab a drug dealer's phone, they'll throw it in the box so that a kill signal can't be sent to it. But we're using it for fuzzing. It's actually quite effective. It's got gloves and everything, so you can actually manipulate the phone, and it does keep it isolated. Next is you're going to need your phone. Just pick your choice. Android, Windows Phone, iPhone, it doesn't matter. It's up to you. When we're doing GSM in our office, we're actually mimicking the AT&T base station using the MNC and MCC values that are listed on the slide. We're using the card that's actually shown on the slide right now. We picked this up at a big box store. Once they're all configured, everything's ready to rock and you can start sending text messages. How much did all of this stuff cost? A lot. Unfortunately. The RF enclosure itself was about $3,000. But of course, if it's an ODA, if you do find an ODA, that cost will be minimal once you sell it to us. So we actually made a lot of modifications to the box. We have a lot of pass-throughs that allow us to do USB through the RF enclosure, do RJ45 connections, so you can actually do network. So we've made some modifications to the box to actually allow us to do debugging when we're fuzzing. The USRP itself, after all the daughter boards and GPS disciplined oscillators and all of that antennae, cost about $3,000. And then the cell phones themselves, unlocked phones, the latest unlocked phones, about $500 with all the SIM cards and SIM cutting tools that you need. So it's about $6,500 to get into the market to actually find bugs in a real world lab setup. It is obviously cheaper depending on your depending on which SDR device. If you're using the Blade RF, which actually supposedly supports OpenBTS now, it obviously would be a little bit cheaper. But I have not successfully got it to work yet on the Blade RF, but we're using the USRP for this. Connecting the USRP on Android, you see on the slides, you just select mobile networks. Once it's up and operational, select network operators. It will search and look for the base station, and it'll find it, and you click home and it'll register itself on the network. Then it will be time to send your text messages like you see on the slide. We have the lead ZDI number. We have a 281-330-8004.
Who? Mike Jones. Who?
1-900 Sir Mix-a-Lot and 8675309 Jenny. You can send whatever you want. You can spoof any text messages that you want. That's what we're doing up here on the stage. Once OpenBTS is compiled with the flags and everything, and you've got it all set up, this is what it looks like when you boot. It's actually connecting to the USRP using that UHD driver we talked about. It looks like this when it's ready to run. Once the phones are connected, you can actually use the timsys command to list the phones that are connected on the network. You guys can have that IMSI if you want it. And then
Mike Jones.
Sending message in OpenBTS is pretty simple, but once you're doing your fuzzer, you're going to want to make it a little more complicated and do little things underneath. Sending basic text messages kind of looks like this. You see the text messages coming in on the phone. Uh-oh. Looks like somebody's getting a shot.
Oh, wait, hey, Mike Jones showed up. Tight.
So we'll continue on real quick. Live demonstration. We are actually fuzzing the phones. You can hear them beeping in the background right now. There's live fuzzing going on the stage using the USRP and our setup. You're more than welcome to come up and check it out afterwards. You can see how much, we've got like thousands of text messages on these phones. And there's also a quick emulator setup.
All right, so for this guy, we just did the remote debugging just to show you this test case. And I just clicked it and bam, look at that. It's all messed up now. Oh man. And then it's going to feed back to the phone saying can't support it, but guess what? Yes, it does. Oh, man.
All right.
Okay, stop. So the last guy tried to do a demo. I said, should I do my shot before the demo or after the demo? He said, we'll do the shot after the demo. He let all of you decide. Demo didn't work. He should have done the shot before the demo. All right, new speakers. You guys have been sucking. Show some love for these guys.
Shots for science, brother.
Because science.
Hey, shout out to T Manning right there. Give a clap for this guy right here.
All right, so final slide. These are attractive targets. There are a lot of data on this phone, a lot of personal information, a lot of corporate information. And this industry really needs a wake-up call from this industry specifically. They cannot handle patches when it comes down to it. If there's a vulnerability that exists in a cell phone, there's a good chance outside of Apple and outside of Google, they're going to have a real hard time patching it. This is the experience we've had with patching vulnerabilities in the mobile space. They really need a wake-up call. And I hope that this industry steps up and gets them to actually do that. It's 2014 or whatever. You should not be sitting here not being able to patch the software that's on a mobile device. I find that unacceptable. There is a decreasing barrier to entry for these for this type of fuzzing. The SDR equipment is becoming cheaper. As we said earlier, you can possibly use the Blade RF to do this same type of research. It is getting cheaper to do this as SDR becomes more popular. And what we've learned is that all of the fuzzing we've done on the desktop, definitely transfers over to fuzzing over here in the mobile space. It's not as hard as it looks. We recommend people get in it. And if you do find 0 days, we are a bug bounty program. We'd be happy to buy them from you. 0dayinitiative.com. A little sales pitch at the end. Sorry about that. But we will buy the bugs off of you. But it is, it's worth getting into. There's a lot of vulnerabilities in this space. And they really need a wake-up call in this industry. So, hopefully you use this information to actually find some good vulnerabilities in these attack surface. Thank you for coming out.
Mike Jones.